Hey guys, we are going to be looking at 4.3 function notation, which then tells us how we can use function notations for operations of functions and evaluating, which will wrap up our function unit. First big news is the quiz that was supposed to be today on 4.1 and 4.2 will be moved to first thing next class. Remember, if 85% of you have your homework done, we'll make it open note. So that's a big thing, don't forget. Continue working on your homework. It is due on test day. If you want to look at the calendar and get that specific date, I can't remember it off the top of my head right now, but calendar's on Canvas. All of your homework problems have been added to that assignment as of today. Now, we're going to work on this 4.3 lesson. If you finish with some extra time, then you'll have time in class to work on that homework. All right, to start out today, we're going to revisit Unit 1 because we will now look at not just operations on expressions, so addition, subtraction, and multiplication, but also operations on functions, which will be very similar. But first thing, let's look back at these. Now, I noticed that this is plus, which means there is an understood 1 here. Well, 5h times 1 is 5h. 7h squared times 1 is 7h squared. Nothing changes. So I bring down my first set of parentheses as well. And I combine like terms. Now that I have everything simplified, it must also be in standard form, which would give me 10h squared plus 7h. For number 2, I use that same idea, except this time that subtraction sign really changes things, because that subtraction sign changes the value of everything in this second set of parentheses, because that subtraction has to distribute. So we're going to see that here. Let's rewrite it. We distribute the negative. We get negative 4s plus 2s squared plus 6. I combine my like terms. We get 2s minus 1 plus 2s squared. Again, we want to give our solution in standard form. The next thing that we had looked at in our Unit 1 was distributing or multiplying polynomials. So here we would take 2x, and we have to make sure it multiplies everything in the second set. So 10x squared, 2x times 4 would give me 8x, negative 15x, and minus 12. I combine my like terms to get 10x squared minus 7x minus 12. For this question, it wants us to evaluate. We know that because it said, hey, when x equals negative 1, it gave you the value of x, so we need to plug it in. Now when we plug this in, everywhere there is an x, we put a negative 1. When you set this up, it's important to use parentheses around any value that you substitute or that you plug in. From here, we grab our calculators and we type it in. But let's say you're like Miss Wheeler, you don't have a calculator handy at home. Too lazy to get your computer out and go to Desmos. We could simplify this by hand, and you're going to use that order of operations. Before we can do multiplication, we have to take care of that exponent. From there, we would multiply, which gives us 13. Now, we talked about this briefly in 4.1 when it said f of 2. We wrote out that this is read f of x, and this means the function of x, which is the same as y, which is the same as y. So everywhere there's an x, I'm going to put a 2. Say 5 times 2 minus 3. 10 minus 3, I get 7. So here, I know that f of x equals 7. I could have said that y equals 7. I could have said that f of 2 equals 7. As long as you have something that the output here is 7. Lastly, this challenge. Instead of replacing the x with just a number, what this is saying is, notice, x has been replaced with 2x. So what I would do is I would say 4. Where the x was, I'm going to put a 2x minus 17. I would simplify that. So this would be my solution. All I did was replace whatever that x variable is with what's inside our parentheses now. When starting the functions unit in 4.1, we briefly talked about that function notation, which you may recognize as this. Now, we also said that this is read f of x. This does not mean multiplying f times x. This means the function of x. When you have f of x, f is the name of the function. X is the input or your domain values, like we talked about last class, input. Whatever the equation portion is, that would be your output. That is your range. So your end result, when you say f of x equals 3x plus 1, you're saying, hey, the y is 3x plus 1. The range is 3x plus 1. So we should notice right here, f of 2 for this situation, where the x was, it was replaced with a 2. From there, we simplified. 3 times 2 is 6, plus 1, we get 7. We do the same thing with negative 4, and we get 11. So let's try it. If we want to find f of 3, when you have the function f of x is equal to 3x plus 1, where the x is, we're going to replace it with a 3 because f of x tells us that x equals 3. So I would set this up. 3 times 3 plus 1 is equal to 9 plus 1, which is equal to 10. Now, remember, if you're not comfortable with writing f of x here, you can always write y, because f of x and y should be used interchangeably. They both are your outputs. So if we move on to our next one, we have g of x is equal to 5x minus 7. Well, g of 5 is equal to 5 times 5 minus 17. I think I said 7 earlier. That's obviously 17. Well, 5 times 5 is 25. 25 minus 17. Go ahead, feel free to type that into your calculator, but you should get 8. Which means we have our 2 functions. We've evaluated them for those values. We can easily try these next two. H of x. You should notice that you can use many different variables to title the function. F is probably your most common, but any variable will work. We would substitute negative. Remember, when substituting in, you put it in parentheses. 2 squared plus 4. When simplifying this by hand, you always do your exponents before any multiplication. So we have a negative 4 plus 4 is 0. Now, this tells us that the input is 2 and the output is 0. Every input and output gives you a point of that function, or an ordered pair. We can do the same thing on the right side. We would say 10 times 1 squared minus 5 times 1 plus 3. 10 times 1 minus 5 times 1 plus 3. 10 minus 5 plus 3. And we get 8. So again, that could be written as the ordered pair. Your input is 1, your output is 8, so you have the point 1, 8. So if we think back to Unit 1, when we did operations of expressions, we added, subtracted, and multiplied expressions. Today we're going to do that same thing with functions. Now, you can also divide, but for Algebra 1 purposes, we're just going to focus on those first 3. Remember, sum is the answer to an addition problem. We would see these problems written f of x plus g of x, or f plus g of x. For difference, we know this is the answer to a subtraction problem, and we are going to see those written f of x minus g of x, or f minus g of x. For product, we know this is the answer to a multiplication problem, and we're going to see those problems written f of x times g of x, or f times g of x. So let's get some practice with those. If we take these 5 functions, f, g, h, j, and k, first thing is I want to add f plus g of x. Well, we should notice that f of x equals 2x minus 3. So to set this up, where f of x is, we're going to put 2x minus 3. We should also notice that g of x is 7x minus 5. So where we have g of x, we're going to put 7 minus 5x. I may have just said 7x minus 5, y'all. My bad. So now we have a addition problem that we know how to work. This is an addition. We would be distributing a 1. When you distribute a 1, none of the values change. So we're just going to go about our business and drop those parentheses. I like to rewrite it without the parentheses so I don't lose anything or confuse anything. And then I'm going to combine my like terms. Well, we got negative 3x plus 4. So f of x plus g of x is equal to negative 3x plus 4. We would do the same thing with h and g. We're going to say h of x is equal to 2x plus 4. So where the h is, we're going to set this up as h plus g. So first thing, we would have 2x plus 4 plus, well, our g of x was 7x, 7 minus 5x. Again, we drop those parentheses. I'm going to rewrite it. If you find yourself missing questions like these, particularly if you missed that opener question, that very first question, I would highly suggest doing this rewriting step and then clearly identify your like terms. Remember, if you don't like the identifying it underneath, you could box one set of like terms where we get 3x, negative 3x, and then maybe circle another set. So we have negative 3x plus 11. We were subtracting with these same 5 functions. If I'm looking at g, 7 minus 5x, and k, 2x squared minus 3x plus 4. All I'm going to do is I'm going to come over here and write it as g minus k Now, here's where it really comes in handy to practice that rewriting step, because here we have to distribute our negative and it does change the value. So I bring down my first set. I now have a negative 2x squared, a positive 3x, and a negative 4. Again, I'm going to combine like terms. Notice I did not select negative 2x squared to be a like term because it does not have the same exponent. A like term is the same variable and the same exponent. Now, I'm not quite done because these are not in descending order. So I'll just quickly reorder from highest exponent to least exponent, and we have our solution. Same thing if we wrote it a different way. Our g of x would go in one set of parentheses. Our j of x would go in another set of parentheses, and then we would subtract them. So j of x would be that 7 minus 7x minus 5 minus g of x, which is 7 minus 5x. I now need to distribute 7x minus 5 minus 7 plus 5x. Combine our like terms, we get 12x and negative 12. So, same drill. If we're saying f and h, we're going to identify f and h. I would say f of x is 2x minus 3. I've tried to color code these to make it easy to follow for you. H of x is that 2x plus 4. Now, we are multiplying these. So what's going to happen here is when we set up this multiplication, these two sets of parentheses are side by side because they are multiplying. There's no addition, there's no subtraction. We want to see that we're supposed to double distribute. So I distribute my 2x, I get 4x squared plus 8x. I distribute my negative 3. Combine like terms. And I would have my solution. Could do the same thing with h and k. H times k So my h of x is 2x plus 4. My k of x is 2x squared minus 3x plus 4. Again, I'm going to multiply these. 2x times 2x squared would be 4x to the third. 2x times negative 3x is negative 6x squared. 2x times 4 is 8x. I then need to distribute my 4. 4 times 2x squared is 8x squared. 4 times negative 3 is negative 12x. And 4 times 4 is positive 16. From here, I would combine my like terms. This is my only x to the third. I have 2x squared. We have 8x and negative 12x gives us negative 4x plus 16. So we now have our solution in descending order. All right, if we look at this first example, we want to consider two different functions, f of x and p of x. We want to find f of negative 2 plus p of 5. So what would happen here is we need to evaluate each function at these given values. So I'm going to come over here, let me change color to make it visible, and I'm going to say, okay, f of negative 2 is equal to 2 times negative 2 squared plus 4 times negative 2 minus 1. I can grab my calculator and simplify. However, just in case you need it, remember exponents come first, so we have 2 times 4 plus 4 times negative 2 minus 1. Well, this gives us 8 minus 1, so negative 1. So f of negative 2 is equal to negative 1. Then we want to say p of x is equal to 3 times 2x plus 5 minus 3, where x is 5. We're going to set this up. Remember, anytime you plug in, we throw that value in parentheses. So we are simplifying 3 times 10 plus 5 minus 3. Now, some of you will want to distribute that, or you can simplify inside first. So we get 42. P of 5 is equal to 42. Remember, that is not multiplication. That's just the title of it. P of, F of. So now, we're just going to add them together. Well, F of negative 2 plus P of 5. We know that F of negative 2 equals negative 1. And P of 5 equals 42. So we get 41. We look at example 2. Here we're doing it from a table. So first thing, let's figure out what W of 3 is. So if I look at my table, this is my W table. I want to find the input of 3. Well, the output is negative 5. So W of 3 equals negative 5. R of 2, here's my input of 2, so my output is 4. So R of 2 equals 4. And we want W of 3 minus R of 2. Negative 5 minus 4, we get negative 9. A graph is the same idea. You find the input and then that will give you the output. So H of 3, notice the graph to the left is H. So we're going to find where X is 3, which will be right here. The point that exists right there is this 3, 4. So H of 3 equals 4. G of 0, we're going to go back. We're going to find where G is 0. So this would be where X is 0. And that gives us that point, 0, 12. So G of 0 is 12. Now, this wants us to multiply the two functions. So I'm going to say 4 times 12, because we did H times G, and we get 48.